Right, so I've got in front of me the Higher 2024 paper. I'm going to do section 1 and section 3. My class didn't do databases, so I'm not going to do section 2. First of all, I'm just going to look at the systems questions. So rather than doing the paper in order, I'll go through, find the systems questions, then I'll go back, do the short response software development, and then I'll do the extended response software development questions. So the first thing in here, as it often is in one of these papers, is about representing numbers. So we have to convert the following denary number, so negative 25, into an 8-bit 2's complement number. Now I've already filled out my little table here. There are 3 steps to convert into 2's complement. So first of all, I need to find positive 25. So to make 25, I would need a 16, and 8 would be 24, and 1 would be 25. And then I just fill in the rest with zeros. So that's me got positive 25. Then I flip the bits, which means that all the zeros become 1s and vice versa. And then I add 1. And this is a nice easy one because it's an odd number. In the last column, I can just add the 1 in there. So 1, 1, 1, 0, 0, 1, 1, 1. And that's my answer. So part B is then to find the largest positive integer that we can represent using 8-bit 2's complement. Now, this is only a 1-mark question. Quite often you would get a 2-mark question where you have to find the range, so you have to find the negative and positive end. But this time you're only getting the mark for the positive one. You're not going to lose the mark if you'd also written the negative one, but it's the positive one that you're getting the mark for. So to find the range of numbers, you would take, if you've got 8 bits, then it's going to be, half of them will be negative and half would be positive. So 2 to the power of 7 is going to be half of 2 to the power of 8. So 2 to the power of 7, negative 2 to the power of 7 to 2 to the power of 7 minus 1 is your range of integers. Then I'm only interested in the positive half of it, so 2 to the power of 7 minus 1, and if I want to work out what that is, 2 to the power of 7 is 128, so it's 127, right? And if you'd written that in either form, you would get the mark. Then we've got a floating point question, and this is a slightly unusual floating point question. You'll see why when we get to the exponent. So there are 16 bits for the mantissa, including the sign. Got a dotted line there, that's to remind us that there's 16 bits for the whole thing here. So 15 mantissa, 1 sign. And 8 bits for the exponent. First of all, the sign bit. Now this is a negative number, so the sign bit is going to be a 1. Then usually what I would do is I would take this, if I zoom in, I would take the decimal point and I would move it left or I would move it right, depending on wherever the first one is, but it's already at the right place. So it's already just before the first one. So that means that actually the exponent is 0. Now I'm sure this probably threw a lot of people in the exam. That actually, you're not having to do anything there for the exponent is 0. The mantissa is whatever's left, so 1, 1, 1. And then I have to pad that out to make it 15 bits. So if I add some groups of zeros, and remember that if you write your answer in groups of 4s, where you can, obviously there's going to be a loose group of 3, that makes it much easier for you to count how many digits you've written, and it makes it much easier for the person marking it as well to see that your answer's right. Then we have to state the effect on the representation of floating point by increasing the number of bits in the exponent. So if I had a bigger exponent, or a potentially bigger exponent, because I could represent a bigger number, then it increases the range of numbers that I could represent. So it increases the range. It's actually quite a big space to write quite a short answer. If you'd been changing the number of bits in the mantissa, that's affecting the precision, but changing the number of bits in the exponent is going to change the range of numbers that you could represent. Question 5, 2 marks for talking about the cache. So computer performance is improved with the inclusion of cache memory on the same chip as the processor. Describe how cache memory improves performance. So you'll need to say 2 things here about the cache. What you could say to start off with is that cache is much faster. So cache is much faster to access than main memory or RAM. Right, and that's going to get me 1 mark right away. I could say what the cache is actually for, that it's used to store frequently accessed data, frequently used instructions. So if I'm accessing that data a lot, it makes sense to put it in the fastest place. You could say that it stores frequently used instructions or data. That would also get me a mark. A couple more things that I could say about the cache. I could say that storing them in that fast cache memory means that I'm having to access the slower main memory less and less. It's fewer fetches, as in the fetch execute cycle. The slow main memory. And if it's found in the cache, then that's called a cache hit. And that means that I don't need to look it up in that slower main memory. So all of those are things that I could answer that could get me a mark. And then if I go to the last systems question, at least that I found right now, a company that's been target of a denial of service attack involving resource starvation. It's a slightly more unusual way that the question has been asked. So describe what's meant by a resource starvation. So resources, by that we mean things like the CPU, the RAM, the amount of backend storage on the server. So if that's being starved, remember that a DOS attack is when you've got overwhelmed, you've got too many connections, the server kind of grinds to a halt. So the server CPU or RAM or backend storage are being overwhelmed, they're being fully used up. So the starvation would be that they're being fully utilised, fully used up, something like that, and they can't handle any more requests. It says with to state one cost to the company as a result of the DOS attack, and the most obvious one is they're going to lose revenue. They're going to lose customers if their website is offline. If their website goes down for a few hours because they've had a DOS attack, then they're going to lose a lot of money.